Alright, kiddos, let's talk about Section 2, matrix multiplication. How do you multiply matrices? Look at this cool font, man. I don't know if you remember this scene or not in the Matrix, but again, it has nothing to do with it. Just thought it was a cool little visual. Anyways, here we go. Let's review. So in this, if you remember what we just did in class, reviewing-wise, when you have two matrices like this one here, it's a 2 by 2. This one's a 2 by 2. You can add these two matrices, remember, because they have the same exact row by column dimensions. 2 by 2, 2 by 2. Remember, it doesn't matter if they're square matrices or not, as long as they have the same dimensions. So for example, yeah, that's a good one. So for example, number 2, this one here you could not subtract or add because it's a 2 by 2, and this is a 2 by 3. So the dimensions, the rows match up, but the columns do not. So that is a no good in terms of adding or subtracting these things. So today, or at least in this video I should say, tonight whenever you watch this, we are going to be talking about matrix multiplication. So what we need to do to take these two things times this matrix times this matrix. Now I will tell you, it's not nearly as easy as this guy where you take -2 and add it to 3, and then take 5 and add it to -1. It is not that easy. It is a simple process, but it takes a little bit of work to get there. So when we multiply these guys, it's not like that. And that is the topic for this particular video. So, here is the most important thing that you need to write down somewhere on your notes. The most extreme importance of all the things that we talk about. Extreme importance. Here we go. It is this. The only time, see it underlined, the only time you can multiply two matrices is when the number of columns is in the first matrix is equal to the number of rows in the second matrix. So number of columns equals number of rows. Now hold on. Number of columns in first equals number of rows in second. So I'll write that down and let's give you a couple examples. So here you go. In this example you see m by n, whatever that dimensions is. It can be any numbers, but m by n. When you multiply that by an n by p matrix, this number of, here it is, number of columns in the first matrix, number of columns, must be the same as the number of rows in the second matrix. That's the only time that you can multiply them. This doesn't tell you how to multiply them, but that's the only time that you can. So it's important to understand when you can multiply first and what happens when we do. So there we go. So there's an example. A 2 by 2 works like a champ. Here's one. This is a 3 by 2. And a 2 by 2. That one works because 3 by 2, 2 by 2, these two numbers right here, the number of columns and the number of rows, are exactly the same. So that would be a legitimate one to be able to multiply. So let's do a couple examples. The question here says, can you multiply them? Now, if you want, just pause the video real quick because I don't want to answer it, but here's the first one. Can you multiply them? Pause it. So the dimensions are 2 by 2. And 2 by 1. Notice this number of columns is the same as number of rows, so that one is absolutely good. You could multiply those. How about this one? It is, dimensions-wise, 3 by 2 and 2 by 2. Notice, oh boy, these guys are exactly the same. Number of columns is the same as the number of rows. So you betcha you could multiply those. Absolutely happy, smiley face to you. How about this one? That looks like a 4 by 2 matrix to me, and a 2 by 3 matrix to me, so these two numbers are exactly the same. So that one is another yeehaw! You absolutely can. A little western in me there. How about this last one? Wow, it's a big matrix. So it's a 4 by 3 and a 3 by 2. You betcha you can, because number of columns here is the same as the number of rows there. So that one is a good one. Let's keep going. How about this example? Let me get to the next one. Here we go. Can I multiply them? Well, that's a 4 by 2, and that's a 3 by 2. Uh-oh! We have ourselves a problem. That's 2 rows. That's 2 columns, and that's 3 rows. So no, we are not able to multiply those. Again, because the number of columns here does not equal the number of rows there. These two numbers up here do not match up. So that one doesn't work. Okay, how about this one? Looks like a 3 by 1 and a 2 by 3. Oh, nope, these numbers do not match up, so that one is no good as well. So there you go. How about this one? It's a 2 by 1 and a 1 by 2. You betcha you can do it. Looks good to me. How about this one? Ooh, the dimensions are exactly the same. 2 by 3 and a 2 by 3. You'd think that you could, but nope. Because remember, this is the key you're looking at. Number of columns and number of rows. So this one is one that you could not multiply. Okay, so let's move on. Extreme importance number 2. As you see with what I just showed you, the number of columns has to equal the number of rows. Well, here's the deal. Once you determine whether you can multiply these matrices or not, why don't we then determine what the new matrix is going to look like in terms of the number of rows and number of columns. You can actually see that as well before we even do any multiplying. Well, here's as simple as this. The resulting matrix will have the following dimensions. If you know the number of rows here is the same as the number of columns there. Wow, I messed up. Sorry. If the number of columns there equals the number of rows here, there we go, then the resulting matrix will have the following dimensions. That's right, M by P. Exactly. So as long as these numbers match up, that means then the new dimensions are going to be M by P. Let's take a look. So what will the dimensions be according to this? Pause your video each time and see if you can get it. Here we go. What's the new dimensions of this going to be? First of all, determine whether you can multiply them. Well, we can. It's a 2 by 2 and a 2 by 1, so this number of columns and number of rows match up. The new dimensions will be? Yep, you got it, a 2 by 1. So back to this. These guys match up, so it's going to be a 2 by 1 resulting matrix. Awesome. How about this one? It's a 3 by 2 to begin with, and a 2 by 2, so you can multiply them. The resulting matrix will be a 3 by 2. How about this one? 4 by 2 is the first one, 2 by 3 is the second one. Those guys right there you can multiply because the number of columns equals the number of rows. So the new dimensions will be 4 by 3. Lovely. That's going to be the new dimensions of that matrix once you multiply. Again, you don't know how to multiply them yet. You're going to find out shortly. How about this last one? Can we multiply these things? First of all, yes, we can, because the dimensions show 4 by 3 and 3 by 2. So these two guys are the same. That's good. What's the resulting dimensions going to be? 4 by 2. Yeah, buddy. You got it. Okay.